own interest, not by the compulsion.
Thank you for your standing presidential address. Appreciation can make a day, even change a life. So appreciate every little thing. It's the time to appreciate the participants and the winners of yesterday's drawing and essay writing contest. There are nearly around 150 participants that participated in this contest. We request our chief guest Dr. N. Lakshmi Narasimhan and our principal Dr. Somu to distribute the certificates for the winners of the contest. Now the prize winners for drawing contest. In the category of excellence, M. Satyabama from 3rd BSc Physics and S. Yakshara from 1st BA English Literature. In category of very good, S. Pratibha from 3rd BSc Physics and R. Jensi Shukla from 3rd In the category of good, P. Vigneshwaran from 3rd BSc CSB and N. Nishant from 2nd DCL. Now the prize winners of essay contest. In the category of excellent, prize goes to S. R. Ramasubramanian from 1st BSc Maths and S. Saran Estarani from 1st BSc Maths. Very good. Prize goes to M. Santosh from BSc CSB and Timmy George Berkey from 2nd MSc Psychology. And in the category of food, prize goes to Anika from 3rd and B. Nitish from BCom. prize winners to come to the podium to take a group photo. With your certificates and prize.
போடா லைவ் போகுதுடா காலேஜ் ஐடி காலேஜ் யூடியூப் நம்ம சேனல் அது வேற வேற பார்த்துட்டு லைவ் போயிட்டு தான் இல்ல கேமரா ஆஃப் பண்ணிருக்கு இப்போ யாரும் எல்லாம் சும்மா நார்மலா நடந்து
including phosphorus, and nitrogen he studied at Uttarakhand Government College, Garud, and after an undergrad and postgraduate PhD, chemistry from University of Madras. He obtained his PhD from Indian Institute of Technology, Madras, Chennai. Further, he carried out his postdoctoral research work at Boham University of Science and Technology, South Korea, before joining CSIR degree. He has 51 publications in international peer-reviewed journals and his H index in 22. He has a recipient of CSIR Scientist of Chemical Sciences for 2001, which is first of its kind in the history of CSIR degree. Currently, he was a Fulbright visiting scholar at Oregon State University, USA. Thank you. Thank you, Ms. for enriching us. Now, Honorable CS Dr. N. Lakshmi Narasimhan to address the gathering.
Very good morning to all of you. So, the organizers of this event, the Vidyan and Mr. Kannavira, who is coordinating the event, and I'm very happy to be here in your college. Okay, so I thank the principal, Dr. Somu, and Dr. Jaykumar, and Professor Sudha, and other faculty members and dear students. So I'm happy to be here to interact with you. Okay, it's not going to be any class lecture or anything. You can freely ask anything if you have doubts. Okay, I'm just going to do some basics and also to cover some of the contributions from Indian scientists. Okay, so why we do this event? As you know, India is celebrating independence, right? So that is the we are celebrating for 1 year, and February 28th is our National Science Day. So to commemorate or to make everyone aware of the contributions of science and to celebrate science in all places. So the Vidyan Sarvatra Pujyate event organized for February 22nd to 28th, and on this occasion, so the Tamil Nadu State Science Council and Ariviyal Palani and Vidyan Prasad, so they are coordinating in this event in Tamil Nadu, and they have several regions. So now they are in the Coimbatore region. Okay, so the topic has been given is achievements of Indian scientists in the field of S&T and future roadmap. Of course, I will cover some other basics also to make it more interesting in the science. Okay, so that's why I always keep science inspires the aspiring mind. So you are seeing the plants. So you feel when you see a fresh plant in the leaves, how do you feel? Fresh, right? So then you will ask why plants are green. What makes the plant leaves green? How it gets the color, how it survives, how it gives the food for us. We use the plants or vegetables, so the color comes from there. So then you start thinking, right? So that is the science. So understanding the science behind our surroundings or nature. So that's how the field grows. Then you try to understand and start making same things in our life, and there is a demand. As the principal mentioned, the green revolution, and there is a demand for food. So how to make? So for which we need to understand first the nature, how it happens in the nature. To understand, then you can also mimic or do the same thing in the laboratory, or you can make more and more, so as the demand increases. So that's why the science inspires the aspiring minds. So before moving this, let me thank all my teachers, professors, and mentors because of the knowledge that I have been given. So today I am standing in front of you and giving this lecture. So I'm thankful to all of them. And also I'm thankful to the project staff and students who work with me. Through them, I learned a lot of new things. And also I'm thankful to our director for nominating me to attend this event. So our institute where I'm coming from is known as CSIR, Central Electrochemical Research Institute. So CSIR is a council on industrial research. So it has all over our country 38 national labs. So each of them focus on different areas of research or science and technology. So our institute located here in Tamil Nadu. So we have mainly focusing on the electrochemistry or energy, like batteries, fuel cells. So all the electrochemical aspects or energy related research is being carried out here. So this institute was founded in the year 1940. Acres of land and 2 lakh rupees cash in the year 1948. So to start this institute, and it started functioning from 1953. Now we are also going to celebrate the 75th year of our institute's foundation day from this July to next July. So we are also completing 75 years. So we have about 110 scientists and 100 PhD scholars and various project students, and also we have a BTech course. So on electrochemical and chemical engineering, which is available only in this place in the country. So we have 40 students per year, so 160 students totally. So it's a unique course. And our campus is very beautiful because we have a lot of peacocks. So you can see they walk near you. So it's a nice campus. So if you get a chance, when things have become normal, you should visit our institute. Okay, coming to the event, Vigyan Sarvatra Pujyate. So the meaning is science and technology is revered all over. Science and technology is respected everywhere. So that's why we should conduct this event to popularize science and take the message to everybody. So how science and technology help, as your principal mentioned, so science and technology only improve our lifestyle. So from the Stone Age to this stage. So how lifestyles have improved, how the facilities have increased, comforts. So that's all because of the science and technology. And as I mentioned, to celebrate the 75th independence, so we have 75 locations have been identified to celebrate this event. So these are the schedules which you can find from the website. So we are in the 4th day, that's 25th February. So the event theme is Science, Technology and Innovation for Self-Reliance for Atmanirbhar Bharat. How to make everything on our own, so without depending on imports. So how to make our own. You know, the pandemic that created a lot of things, but one advantage it created is we realized what is our strength. How to make the vaccines, how to change our existing medicines for repurposing for this particular virus, and also to make the ventilators without import, how to produce the ventilators by ourselves. So that is one of the major advantages. How we realize our own strength. So that's why it is self-reliance or Atmanirbhar Bharat. Okay, so we have India has the glorious past in science and technology. We have several names. Of course, I cannot cover all of them in this short time, but a few of them I'm covering here. If you look at Aryabhatta, so you might have come across this name Aryabhatta, mathematician, because he only started using the symbol 0. And also, he is not only mathematician, he is also astronomer. Okay, so he also derived the value of the pi, 3.14. So that is from India. He has a book on Aryabhatta. It's a compendium of mathematics and astronomy. And similarly, Sushruta. So he is a surgeon of old India. He also made the plastic surgery, dentistry. Now we know plastic surgery. If you want to change your nose, you feel you are not beautiful. So it changed, am I right? But it has been done long back, in the year 800 to 700 BC he lived. So he is the first surgeon of India. And he has written a book, Sushruta Samhita. It's a Sushruta's compendium. So of course you can find, as we know, it's the information age. So you only need, previously we used to say, the knowledge should be fingertips, right? So when we study, they say you should be having everything in your fingertips. Now, fingertip is more important to type in Google, right? If you need any information, you can use only 2 fingers to type in your computer keyboard to get a lot of information. So you can get every information. If you go to Wikipedia, you can get all information. So how we use this information to improve our knowledge. And we also have Jagdish Chandra Bose. So he is a botanist, biologist, as well as physicist. Actually, the Institute IEEE named him as one of the fathers of radio science. He also discovered the radio at the time when Marconi discovered. So he also contributed. And another invention of him is the SCoP, that is to measure plant response to various stimuli. So plants you might have studied in your higher secondary school, depending on where the light is available, the plant starts bending. Am I right? So that is how the stimuli, depending on the stimuli, how it changes. So you can measure using the SCoP. So that's discovered by Jagdish Chandra Bose. And also another Bose is Satyendranath Bose, SN Bose. So he is a mathematician and physicist. He contributed to particle physics like quantum mechanics along with Einstein. So he proposed Bose-Einstein statistics, and the particles are also named after him, bosons. So to remember him, so the Bose name is given for these bosons. There is a particles that obey the Bose-Einstein statistics. And other names, we know Chandrasekhar Venkata Raman, C.V. Raman. So C.V. Raman, so who is a physicist and discovered the Raman effect, light scattering, and the Nobel Prize in Physics in 1930. So he is the one and only Nobel laureate who worked in India and obtained the Nobel Prize and lived here in India throughout his life. And then his own students, K.S. Krishnan. So he is also the co-inventor of Raman scattering and the physicist. He was also a former director of National Physical Laboratory in Delhi. There is a road named by K.S. Krishnan Mall in New Delhi for his contributions. And Srinivasa Ramanujan, everybody knows for his talents in mathematics. He's a mathematician. So he's associated with the number theory and infinite series, and some other contributions have been made by him. Unfortunately, he died at very young age due to illness. And another important name is G.M. Ramachandran. So he's a physicist or biophysicist. So he created a plot, a graph, Ramachandran plot, to understand the peptide structure. So that is known as, he only proposed the triple helix model for the collagen structure. So he is also famous. So Ramachandran plot is well known in the field of biologists. Okay. And engineering, so you can see Sir Visvesvaraya. So he is a civil engineer and a statesman. So he built the Krishnarajasagara Dam in Mysore. So his birthday is on September 15th is celebrated as Engineers Day in our country. Okay. Of course, we are all science students, but we may know this from now. So September 15th is the Engineers Day to commemorate the birth anniversary of Sir Visvesvaraya. And in this region, the another famous name you all know is G.D. Naidu, okay, from Coimbatore. So he is also an engineer and inventor. So even though he didn't get a formal education, but he invented many things, especially he is considered as the Edison of India. So he made the first electric motor in India, and he also had a transportation we had the transport department buses running in this region, I think from Pollachi to Coimbatore or Parani, somewhere. So he had a company called National Electric Work in Coimbatore. So he has made a lot of discoveries. So that shows that you don't need a formal education. You only need a curious mind. As I say, why plant is green? Just ask some questions. So then you can become an inventor. So how to modify depending on our time. So what is our requirement? So if you think something creatively, you can get an innovation. So another important name in our lifetime is Dr. APJ Abdul Kalam. He's an aerospace scientist. He's also known as Missile Man. So his contributions were in the space research and missile development. And he served as former president of India. And we are proud that he encouraged everyone to dream. So to dream to become a great person, to make discoveries. Okay, so Dr. Abdul Kalam is one of our lifetime we are seeing. Am I right? The other people we have not had a chance to see. At least we lived in the time of Dr. Abdul Kalam. So we must be proud. Okay, so with this, let me also move. Another one is Acharya Sir Prafulla Chandra Ray, who is considered as father of chemical sciences in India. He is the founder of the first industry in India, the Bengal Chemicals and Pharmaceuticals, the first pharma company of India. So he studied in UK in University of Edinburgh. He got the Doctor of Science. His thesis is conjugated sulfates of the copper magnesium group. So a study of isomorphous mixtures and molecular combinations. But in India, he first discovered the mercurous nitrate in 1896. He just added mercury to nitric acid. Of course, chemists may know this. So then you get the mercurous nitrate that has made a great impact among the world scientific community. And also women in science. So you may ask that we are also here. So we also contribute, of course, yes. So we have several names. I covered a few. So E.K. Janaki Ammal, she got a doctorate in Michigan, US, and she is a founder fellow of the Indian Academy of Sciences in Bangalore. So winner of Bhatnasri Award. She is known as a botanist and plant psychologist. And similarly, Anandibai Joshi. So she is the first woman to obtain a medical degree in the Western Hemisphere. So she got her doctorate, I mean the MBBS, medical education in USA, but unfortunately, she also died at a young age of 22. So she lived between 1865 and 1887. Imagine those years going to abroad to study medicine. So it's not easy. So parents may not allow, the society had restrictions, but still they all contributed. And Chatterjee, she is also the first woman doctorate from Calcutta in 1944. And she also received Padma Bhushan and Bhatnagar Award. So she contributed mostly in the natural products, special reference to medicinal chemistry. So she received Padma Bhushan and she established the first tissue culture laboratory in India. She founded the Human Association. So she got a PhD in 1970. Area mathematics or physics background. So you get a lot of information. If you visit the Academy of Science website, they have a book on this women in science. I have taken only a few here, so you can also go through this. And if you look at women in science, you come across the name very few. What chemistry as well as physicists, they all know for discovery of the radioactivity. Right? She is also rejected by the university because she is a woman, but she never gave up. So she is the first woman to win Nobel Prize in physics and first person to win 2 Nobel Prizes in physics and chemistry. So you can see what she can be less curious about people. Don't worry about people. Be curious about ideas. Then you can become successful. So now I come to the science. So we are all studying the science subject. What is science? How do we define science? Have you thought about this? Okay, so let us just look at the dictionary. So Oxford English Dictionary. So what is science? Go to the word science. It defines the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. As I mentioned beginning, you see the physical or natural world, why plants or green, plant leaves or green, how they produce the carbohydrates, the food. Then you conduct several experiments to take that leaf, analyze what is there in this, what causes the color of this, how it converts, it takes the CO2 from the atmosphere and water, how it converts to carbohydrates, the food, what we consume. So then you do all these experiments systematically, try to understand, then now we call it as a photosynthesis. Am I right? So photosynthesis is what happened. So understanding that, carrying out experiments, observation and experiment, and systematic study, or a systematically organized body of knowledge on any subject. It's not only on the plant, it's also on the other subjects. How the layers are caused in the ocean. So how to convert the winds into energy. So a lot of things. So that's how the developments have been made. You might have seen a lot of windmills in this area. So why are they present here? Because this part has more wind, so you can convert, as you know, energy can either be created or be destroyed. And it can be converted from one form to other. So convert the wind energy into first mechanical energy, then electrical energy. So wind, it rotates the blades, so then you convert it to electrical energy stored in the batteries. So that is the way the science. Also, according to Albert Einstein, the whole of science is nothing more than a refinement of everyday thinking. So first day, probably our ancestors saw the plant, why it is green. So they may be thinking it's a color comes from somewhere, but then some experiments, then they change the idea. No, there are some molecules present in the leaves, and these molecules are responsible. They absorb the light. There is a chlorophyll. So there are some complexes, coordination complexes, they absorb the light. So that means you refine your everyday thinking. So that's the science. So you keep on changing. Suppose today I am saying something, you can come back tomorrow, do some other experiment to disprove me. What I have told is not correct. There is something else is happening. You can provide correct reasons. So that's how the whole of science is nothing more than a refinement of everyday thinking. So again, when we talk about Einstein, I also put something here when light meets matter. See light, I am using this laser light. Suppose I send this laser light to this bottle. So the light is going the other side, am I right? Why? Or through the window. What happens to the light? It transmits, am I right? Because it's transparent. The glass is transparent. The same light, if I shine on a metal, what happens? Whether it goes to the other side? No. Whereas here, at least I can see something. If I take on the other side, my hand, it may come. You see here, I'm sending through this bottle, water. So I'm seeing the light coming here because this is transparent. But metal, if I shine, it's not coming because what happens is, it's opaque, it scatters. So light gets scattered or reflected. So that's what the study has been made. Right. Oh, sorry. So when light meets matter, what happens? So that I will come back to that. And what is technology? So we have defined science. Now what is technology? So the application of scientific knowledge for practical purpose. Whatever we do in the laboratory, so how to convert it to useful form for the humankind, for our day-to-day use. You discover it later in the lab, fine. But how do you make it in the product so that I can use here? So I can use this as a pointer. So that's why we need the technology. So the engineers help we need. So they can design to make it into small products. So the machinery and equipment based on such knowledge, known as technology, or the branch of knowledge concerned with applied science. So you also heard about applied chemistry, applied science. So that's how it's an application-oriented studies. So that's called technology. And then what is innovation? That is a change something established by introducing new methods. So how do you think, can you give some example? What is the innovation? Change something, what we use. As we heard from your principal, you said the olden days the telephones. So you have to ring, it is connected through a wire, it goes to exchange, from there to it transmits to other exchange, and from there to other home where the other person receives the phone. But somebody thought, I don't want this wire. How to remove this wire and still make this phone working? So then it has come, wireless phones have come, cordless phones. But now we don't still need any wire outside. So we use all from our small device called mobile phones. How it communicated through satellites. We have a receiver to use the microwaves or radio waves. Through radio waves, it is transmitted to satellite and you get all the covers. So that is the innovation. Something you think differently, new way. I want to replace, I want to break this pattern. So that's called innovation. So innovative means featuring new methods or original ideas. So that's called creative thinking. So if you are creative, then you can make your creativity into innovation. Okay, as I mentioned, the light means the matter. It was Michael Faraday, who is again considered as the father of electrochemistry or even magnetism. So he also never got a formal education, but he has contributed more. The first electromagnets he made, and electrochemistry, lot of the electrochemistry laws, Faraday laws of physics. Okay, so he was interested to study experimental relations of gold and other metals to light. When you shine light on metals, so what happens? That's what I told. It scatters, am I right? So he prepared a colloidal gold. How he prepared? You can see here. This is a colloidal gold solution prepared by Michael Faraday. So still this is available in the British Museum. So it was prepared in 1857. How he prepared? He has taken sodium chloride where gold is 3+. So you take in dissolve in water, then add to carbon disulfide solvent that contains the phosphorus. So phosphorus is the reducing agent here. So once you add this, so it reduces the gold 3+ ions into metallic gold. So you will ask, so where is the gold? I cannot see. I know gold is yellow in color. It should be the particle or it should be a pieces. Where is it? You don't see that. Am I right? So that is because the sulfur in this can act and surround these gold particles. So that two gold particles cannot come. If you have several gold particles coming, gold atoms, then you form a bigger particle. So then you can see whatever we wear, the ornaments, so it's all having bulk gold. Several particles, several atoms of gold are there. Okay. So, but here you have the sulfur that goes and surrounds the gold so that the other gold cannot come together. So he called this as a very minute in their dimension. But nowadays, so we have a name for this. Anyone knows? The size is so small. Exactly, very good. So nanoparticles. But in those years, the word nano was, nobody knew what's nano, what's the dimension. what is 24 minus 9? No one has any idea because you cannot see. Okay, so that is how he was having this. He was studying for the interaction of the light. Okay, so he published his paper also. But later, it was Heinrich Hertz and Philip Leonard. So they, in 1887, what they did is they just shine light on a metal. So they found the electrons are ejected. So they emit the cathode rays. They are nothing but the electrons. So then they made this experiment so they could get a cathode rays out of this. But you know, these electrons are particles, right? Protons, neutrons, electrons. So we know they are particles. But then what they say, you are shining a light. Light is a wavelength. Maybe if you use a visible light from 400 nanometer to 700 nanometers. But how it can produce a particle? So it's quite opposite, contradictory. To shine a wave, I should get a wave. Right? So that's what they questioned. But it was Albert Einstein in 1905. He proposed that light can be considered as particles. They call it as photons. So now we know that electron also has dual nature. It can behave as both particle as well as wave. So Einstein explained this photoelectric effect by considering how much energy you are giving, and depending on the metal's work function, the remaining energy is given to the electron coming out. So he published 3 important papers in this year, 1905. It's called Annus Mirabilis. It's a miracle year. And in 1921, in physics for contributing to theoretical physics and mainly explaining this photoelectric effect. Okay. So then another important name associated with the light is Percy Raman. So Raman was born on November 7, 1888 in Tiruchirappalli, in Trichy, here. Okay. So he had his higher education in the Presidency College, Chennai, with masters. Then he was working in accounts office in Kolkata. So, but his routine is morning 5 to 9, he set up a lab. He worked in the lab. Then 9 to 5 in the office, in the accounts office. Then again evening 5 to 9 in the lab. So 8 plus 8, 16 hours he worked every day. Because he was interested in science. Though he was working in accounts office for survival, so we need some job. So, but his interest in science. So he was working in the lab. So because of his interest, later he was appointed in Kolkata University in 1970 as a research professor at the age of 28. But in 1921, you know, at that time it's the British India. So he was traveling to the University of Oxford to attend a conference, Congress of Universities at the British Empire at Oxford. He was traveling in a ship in 1921. Then he saw the beautiful color of the sea, blue color. So he was thinking why the sea looks blue. Why it is looking blue? It's a reflection of the sky. Okay. So that is how everybody was thinking. The blue color of sea water is a reflection of sky. Okay. But then he had a question, is it only due to this? So that's how he questions why it looks blue in color. Okay, he had this question. So that's what we say scientific way or scientific thinking. So you have to question something in your surrounding. So later, when he looked at, you can see that Lord Rayleigh explained in 1904, he was awarded the Nobel Prize in Physics because he said the light, sunlight is scattered by gases in the atmosphere. So the blue light is the scattered the most. The layers of blue because there are a lot of molecules. So they, or the gas molecules, they scatter the light. But Rayleigh scattering is considered as elastic. That means if you throw a ball on a wall, the speed with which you throw it should come back at the same speed. That is your elastic scattering. So that's what Raleigh explained. But later, Arthur Compton explained the inelastic scattering. It's not elastic. When you throw a ball, some energy is transferred to the ball, so remaining energy only comes back. So it's not the same force or same energy you're getting back. So it's called inelastic scattering. Compton also awarded the Nobel Prize in Physics 1927. But Raman and his students started working in 1921. Why the seawater looks blue? So they found a strong color change when light scattered by glycerol. They have taken a glycerol. Okay, consider this is a glycerol, this bottle, then you send a light of a particular wavelength, analyze what wavelength comes out. So they found the color is changing. When you shine a blue light, you get a green wavelength outside, green light. So here, you send a blue light to this glycerol molecule, or if you consider this is like a water molecule, right? So glycerol is an organic molecule. So there are a lot of vibrations in the bonds. So in the molecules, two atoms are joined through chemical bonds. So there will be vibration because we are not at absolute zero Kelvin. We have energy. Room temperature, we have 25 millielectron volt energy. That's enough for the vibration. So, for example, see here, the molecules will be always vibrating like this. The atoms will be moving, or you can see here. So you shine a light of blue through this molecule. So the molecule is vibrating. So some energy is taken from this light to the photon. The energy is transferred for this. Then whatever is coming out is having a other wavelength, other energy. So E equals hc by lambda. So energy is related to wavelength. So different energy, so that means different wavelength. So then Raman explained this kind of scattering. So Raman found that it's no more elastic scattering. So there is a SCoPs and anti-SCoPs. Sometimes the energy given to the molecule, so the energy coming out will be less. So that is the input energy is high, the output energy is smaller, it's called SCoPs. Or the other way, sometimes the energy is given from the molecule to the light, so that's called anti-SCoPs. So for this discovery, Raman was awarded the Nobel Prize in 1930. So they discovered this effect, light scattering effect, on February 28, 1928. So this effect was discovered. So this is the spectrometer he built. One Raman spectrometer. So he was explaining to all the foreign scientists who visited to understand this Raman effects. These are some of the pictures, so we also impact the school children. He built an institute called Raman Research Institute, which is in Bangalore. So he mentioned that the real growth of the country was in the bodies and souls of all of you, young men and women, including me. Okay. So we are considered as a student all the time, scholars. Okay. For learning, there is no age limit, or nobody stops you to learn. So you are always scholars, lifelong. If you only need the interest to learn. Okay. So in the history of science, we often find that the study of some natural phenomenon has been starting point in the development of new branch of knowledge. So this is what he mentioned in the Nobel lecture. The Nobel laureates have to give us lecture after receiving the Nobel Prize. So he delivered, usually these lectures will be in the during the December 10 and 11 every year. So he mentioned this. So what is found that in the natural phenomenon, he started seeing why the seawater is blue. So that is a starting point of some discovery. That's how I said photosynthesis. The plant leaves are green. So if you question that, so you can build something, you can come up with some new discoveries or some new science, new branch of knowledge. So that's a Raman effect and Raman spectroscopy. That's the one which has come from that time. So science is inspiring by studying the nature. So this is the Raman spectroscopy application. So you can find out the difference. So you know diamond. So diamond is another form of allotrope of carbon. Okay, but it's only forms only at high pressures, only at the earth crust. So high pressure we need. Of course, now we can make artificial diamonds in the laboratories by applying high pressures. So, but that can be also have a crystalline. Sure, thank you. So the crystalline diamond and nanocrystalline diamond. So how to differentiate? You can use the Raman spectroscopy. So you can see this piece is very sharp. That means it shows crystalline. Or this is having a amorphous or a nanocrystalline. So you can see it's a broad. So that's how the Raman spectroscopy can be used. Or you can also use until the discovery of laser. Raman spectroscopy was not much used. But once the laser was discovered in the 1960s, then people used the Raman spectroscopy because you can use a monochromatic light, particular wavelength. So then the Raman effect of the Raman spectroscopy has become more and more useful or application wise. So you can also use to understand the surface. If you have some molecules on the surface of the metal, so you can see the signals are enhanced. So that is known as surface enhanced Raman spectroscopy. Or you can also study the tissue of a human tissues using the Raman spectroscopy. So like this, so what are the Raman scattering of a targeted cell organelle? So you can find out what is the constituent. So a lot of applications have come for the Raman effect, which Raman never thought this will have so many applications. Am I right? When he discovered Raman spectrum. So it is how people later think creatively. So how can I use this spectroscopy for different applications? So that is called innovation. So now it's useful in many places. So to commemorate the discovery of Raman effect on 28 February 1928, so our government started celebrating this from 1987 onwards, celebrated as National Science Day with the different themes. And this year's theme is Integrated Approach in Science and Technology for Sustainable Future. How science and technologies are combined together or contributing for our future, sustainable future. So there are several policies I can just briefly go through. So Indian government has made several science and technology policy. The first year it was made in 1958. So this time the focus was nurturing scientific enterprise and temper, and science and technology as an instrument of socio-economic transformation and nation building, and cultivation of scientific enterprise in pure and applied science research and capacity building, and opportunities for scientific activity, discovery, and dissemination of new knowledge, and creation of several scientific organizations, national laboratories. That's how CSIR now has 38 laboratories. So each one has been created various time periods. So as I mentioned, our lab was created or founded in 1948 after the independence. So the strong foundation for R&D and higher education was given importance from the first or the science policy from 1958. Then in 1983, the technology policy. So here it was given importance to the technology to influence life and bolster societal expectation. How we can make use of the technology for the humankind, for the society's benefit. So maximize utilization of local resources, whatever is available in that particular place. So how to make it more useful. So strengthen technological self-reliance in new sectors like information, electronics, and biotechnology. Of course, we are all well aware that the information technology India has made a huge impact on information technology. Am I right? So that's why. So most people go to study information technology or computer science. So because we get more jobs, but it's not only in the information technology, we also have a lot of scope for other subjects as well. The electronics or biotechnology. So again, biotechnology involves biochemistry and engineering. So everything is combined. So interdisciplinary these days. If you say I'm only chemist, I'm only physicist, no, you need a combination. If you discover something in the lab, you need to understand the properties. So physics knowledge is required. And once you make that, then you want to make a product. So we need the help of the engineers. Am I right? So you prepare a few grams in the laboratory, I want to make kilograms. Then we need the help of chemical engineers to scale up. So products. So I want a nice design of this laser pointer. So then I need mechanical engineers or manufacturing engineers. So how to make it a more attractive product? The cell phone designs. So every time it changes, am I right? So earlier it was only one camera, now it has a both front and back camera. So how people think, what is the need? How to improve? Am I right? So that's all the technology. The establishment of technology development fund was created, and technology information forecasting and assessment firm TIFAC was created in this period. And in 2003, the recognition of science and technology enterprise intertwined both science and technology to go together. So unprecedented impact of growth in information technology. So initially we didn't expect this much growth will get, but it's good for the Indian economy. So we got a lot of our economy has improved. So IT sector has attracted global business, right? So and democratization of internet on socio-economic growth and development. Now, especially this pandemic has created, you all, without breaking your studies, you sit at home and you continue your classes. How it happened? Because of the internet. Am I right? So even today, I can give this lecture from my own home, sitting at home. Am I right? So this is the first time we travel because now the conditions are better. So it is possible. So information technology and the internet, which we never imagined, right? So invest heavily in R&D and modernize S&T infrastructure in academic institutions. And similarly, several Indian Institute of Science Education Research have been started, and several new IITs have been created based on this policy. So in 2030, it's a decade of innovation from 2010 to 2020. So intend to penetrate SDA to transition to a knowledge-based economy and aim to position India among top 5 global scientific powers. And also the innovation is the key to build S&T innovation ecosystem. So linking this science, technology and innovation to socio-economic priorities. How this can be useful for our society. How we can create economy through this. They are steps to build robust national innovation ecosystem and India's leadership and participation in global mega science initiatives. For examples, we know the space science technology, India's growth. Talk about Chandrayaan. So we never imagined we'll launch satellites or send to moon, am I right? To the mission. So now it's possible because of the science and technology. And similarly, the COVID-19 pandemic, India's role in making ventilators and vaccines. So the whole world appreciates. So we could vaccine for people in a so fast, am I right? So that's all the science and technology. The innovation or raising to the occasion. There is a need how to unite people and come up with the new ways and new technologies. Okay, so science, technology, and innovation, all three have made strong impact in education and work and skill. So you have several online education systems that's because of the technology, and you can get a lot of work also being done. Even you don't need to go if you are working in information technology. So you work from home and solve the problem of your customers. Just log into their computer and solve the problems. And the skills have been improved. So you watch several YouTube videos, lectures. So you can also learn by doing do-it-yourself experiments, am I right? So several such knowledge is available. Okay, I just covered a few things. I think I have time. So let's look at one example here, artificial lighting. So you know to create light. During daytime we have sun, so you get the light. Can you imagine a world without light? Suppose there is a blackout, there is no power. So how long you can stay dark? And for 24 hours there is no light, it's completely dark. What will you do? How we survive? What happens to our psychological effects? In some part of the world, especially in Norway, in Oslo, 6 months the sunlight comes for only 1 hour, and 6 months the night comes only 1 hour. Okay, but if you see there is no sunlight, your mind also will go down. You will become gloomy, moody. So once you see morning when you see sunlight, you become brisk. Am I right? So light is essential. So after sunlight, so we need to live. So we need light. So what our ancient people did, they started finding out the ways to create fire using stones, and then they discovered different things. So they used the fire for the lighting in the evenings. And then the candles were discovered on the lamps, and then the bulbs. Thomas Alva Edison discovered the incandescent bulb. Then later it was changed to tubes, fluorescent tubes, because it consumes less electrical energy. But now we are using the LEDs, the semiconductor light emitting diode based LED lights, because it consumes less power. So you don't consume this much power in the incandescent bulb, which uses 40 watts, 60 watts, and it produces a lot of heat, right? So, but now you can use only 10 watts, 11 watts. And also the fluorescent tubes, again, there was mercury inside to make this process. So when you dispose your used lights, so you're also throwing mercury to the environment. But whereas with the LEDs, there is no mercury, they are safer. So that's how if you look at the efficiency of the lights from various years, so you can see from 1900, the incandescent bulb was discovered in this period. Then the halogen lamp came, the fluorescent lamp came in 1938, but LEDs came in the late 90s. So then you can see its efficiency is increased so rapidly, a vertical growth. So now we want to replace all the lights to save energy and to have environmentally friendly lighting. So we can also use different balanced elements. You look at periodic table. Of course, chemistry students know periodic table. Everyone has studied in the school, am I right? So there are rare earth elements, the lanthanides and the actinides. So the lanthanides, they have a specific emission colors, whereas we use transition metals like 3D elements. So they also emit, but they have a very broad, because there is called a crystal field splitting, the d orbitals are affected, but this uses the F electrons, which is inner, so they get a different short colors. We use europium, you get an orange red or red emission. So dysprosium, you can get yellow, or terbium element you use, you can get a green. So this just to show how the periodic elements, so you can play with them. So they have a different property. That's how they are arranged based on their properties. So you can get the colors from them when you excite. So you might have seen in the market, glow in the dark toys, or you can put this paint in the star or moons in your roof. So when you switch off the light, you can see they will be glowing. So they are nothing but they have earlier it was the zinc sulfide base, but now you can use the strontium or aluminum oxide with the europium or dysprosium. They can glow for 12 hours. Just you shine light for a few minutes, enough. So that's all again, it's a science. So how to use that science in a creative way? Somebody thought, okay, this compound is glowing, this powder, then make it in a paint, mix it with paint, then coat it, paint it. So you can use in a signboards. Suppose you are using this exit, there is no power. emergency, people can exit, there will be direction. So that's how the innovation, creative ideas. So the LED light uses a solid state lighting we call. So you have the LED chip, the semiconductor diode. So that chip, when you connect with the power, so it emits a particular wavelength. So then you coat another phosphor powder, the luminescent powder, which emits different colors, so combine them to get a white. So these are important because you can save the world electricity consumption by 50% to replace all the lights with the LEDs. So because once you are decreasing the electricity consumption, you can also reduce burning the fossil fuel to produce the electricity. Okay, this is just the basics how you produce the LEDs. The semiconductor, so you might have studied this is in the physics textbook I have taken. So you also studied this P-type, N-type semiconductors. So how to create with N-type, adding an extra element in silicon with phosphorus or arsenic, or if you want to substitute with boron aluminum, there is one electron less, so you can get a P-type. So, but if you make P and N junction, then you get a light emitting or other diodes. Okay, so then based on that you can get a light emitting diode. So this is how we create a diode, semiconductor junction. So you have one type P type, another type N type. So once you connect them, the electrons move in opposite direction and the holes move. When they move, they recombine. By that way, they emit the light. They give away the energy in the form of light. So you can also get how to get a white light. So white color. What is the color white? Combination of 7 colors. So what are those 7? VGR. Very good. So it covers from 400 to 700 nanometers. So if you have a prism, you can separate them, right? So that is how white light can be generated. Or white light is a combination, equal combination of the primary colors, blue, green, and red. Because you can create other colors by mixing in a different proportion. So you can see color wheel. So either you can mix, you can take 3 LEDs, one is emitting blue, another emitting green, another emitting red. So you can mix them, you get a white light. Because we need white light. We cannot always use blue or red. We need white for our normal activity and purpose. So this is one option. But again, the problem is you cannot mix, it's not easy. So it's all unidirectional, the LED light. So it's a different engineering is required. The other one is you take again a near UV LED, so which emits just below 400 nanometers. You can coat with 3 different color emitting phosphor, like I mentioned, the luminescent powders. So one emits blue, another red, another green. So they can be excited by taking this energy. So you can get a primary color in white light, or whatever is commercially available is the blue emitting LED. So the blue light is coming from this, and you coat a yellow emitting powder. So again, yellow is a combination of red and green. So now you mix all the primary colors here. So the blue light is partly absorbed by this material, so that it gets excited. It goes to the higher level, then it emits, it comes back, giving yellow. So you see both the blue and yellow, so you get a white light. That's what we are using commercially available one, right here. So this was made by company in Japan this year. So you have the blue LED gallium nitride, and you have the compound yttrium, aluminum oxide, helium. So that gives a yellow emission. So you coat that powder on a LED chip, then you pack it. Okay. So that's how you see that white LED, small ones. So if you look at the spectrum, so this is the blue region coming from the LED chip. This is the yellow region coming from the powder. So you are mixing in a proper proportion so that you get a white light. You cover entire region from 400 to 700 nanometer with GR. So you cover this, so you get a white light. Of course, we have done some work on this kind of powders phosphorus. where you can get a white light from a single material, not 2 or 3 different material. So we can prepare a single material. So we can have a ions which can emit blue and yellow. So then you can get a white light. So you can also put on a LED chip. Tested this. Or we can also have a different element or different compound. So that's how we can play. So you choose different compounds, different elements, and play. That's how the research goes on. So to improve the efficiency or the color properties. So this is how we made a blue emitting compound and a yellow emitting. But when you have both together, so you should get a white. But of course, this white is not very bright, but you can improve them by certain modification. So now we know the televisions, how the LED lights are used in the television. So earlier television or the computer monitors, you know, the cathode ray tube, it's too big. But now we have the LCD displays or LED using the backlight displays. So that's how the technology or innovation. I don't need to occupy a space. How to minimize. So that's the technology. So imagine how to replace this, the small size. So you are using these LEDs in the signals, traffic signals, or you can use in the signboards, or entry exit signboards, or now the LED TVs. So these are 3D TVs. So on the London Bridge, so all the light bulbs are replaced with the LEDs, so that they could save electricity consumption. And these LEDs, so also again, it went to a Nobel Prize in Physics in 2014 for the discovery of blue LEDs. So now you ask a question, LEDs, there are red, there are green, there are orange. We have seen these are used in electronics for several years because they have been discovered in the 60s. But why only for the blue? Because it was very difficult. So they struggled for 20, 30 years to make this LED because it's a gallium nitride making a thin film. It was not easy for them. So it was awarded to 3 scientists, Isamu Akasaki, and Shuji Nakamura, and Hiroshi Amano. So they started working on making this gallium nitride from the 80s, and then they made this thin films, so it was not easy. Then once they made it, they could get the blue light. So without blue, you cannot make white. Am I right? So that's why this one got very important. So you can see, his question was, I want to replace this television tube, a small one. That's why he was doing research. So this is quite Professor Hiroshi Amano's, okay? So they started from 1967 onwards. So it takes 20 years, so even though they work, but now the application, any Nobel Prize you take, that should have an application to the humankind, it takes years. Nobody knows. When they discover something, they don't even know this will get a Nobel Prize. Nobody wants to get a Nobel Prize, but it all happens the long way. Somebody uses this technology, so then they discover, okay, who discovered this? That's how it goes. Okay. So these LEDs now, you can see in many places, like in India, there are remote places where you cannot put the electricity through the grids. You cannot connect the grid line in some remote areas, in the mountains or forest region. So those students also need to study like us, right? So we are living in a more comfortable place where you have much more comfortable life with electricity, everything. But there are children who are living in the rural or in the region, but there is no access for the electricity. So, but once you have the LED, and another one is solar panels. So you can install solar panels, put a battery. The daytime the sunlight is converted into electricity stored in a battery. So that can be used to light these LEDs. So you don't need any wires to connect anything. You need only batteries. So LEDs can come for long life. Okay, so it can come for 1 lakh hours compared to other bulbs. Okay, so that's how it do not consume much power also. So that's why they can use it for their studies. So that's how the humankind is using these discoveries. So another discovery as in the batteries. So I also want to show here battery. So it was in 2019 for Nobel Prize in Chemistry. It went to Professor John Guggenheim, Professor Stanley Whittingham, and Dr. Akira Yoshino. So for the discovery of this battery material, which we now use in all our watches, everything, the lithium-ion batteries. And now it's planned for the vehicles also, electric vehicles. So how they discovered, it was also started from the late 70s and then 80s. So it was Professor Whittingham started working on sulfides. So he could make a 2-volt batteries by using a lithium insertion. But later, Professor Guggenheim showed that you can make a 4-volt by just replacing one of the material used in the cathode. But still they were using lithium metal as the anode, but it was causing the problem. You cannot handle lithium outside, so it will catch fire. So, but later this was made by the Japanese scientist. He replaced some of the graphite carbon form. So then you can use FEGs. Then the Sony commercialized lithium-ion batteries in the 90s. So that's why they awarded this Nobel Prize. So at the time, 2019, for the Guggenheim was 96 years old. Now he's 99 years old. Still, he works in the lab. He's active. Okay, he has an interest, passion. That he wants to make another breakthrough in the same field. Okay, that's how people think. Once you enjoy doing your science, okay, age doesn't matter. You enjoy your science, your experiments, your research. That will drive. That's a driving force. So enjoy your subjects. That's the physics, chemistry, or mathematics. So you just enjoy. Try to read your subject more with understanding. Okay, not just by memorizing for the exam and forgetting after that. No. Okay. As I mentioned, now we are living in the information age. Only fingertips to type in Google, you get all things. So you can get more knowledge, whatever not available in your textbook. So you can get much more. Okay. So that's a passion that drives them to contribute more. Okay, another thing probably I can rush through. So there is a cup. I can show you. This is called a Lycos cup. It was made in 4th century. It is also available in the British India. So it's made of this type of glass. You can see what is the color you are seeing here. So it's an inside metal, outside it's a glass coated. What is the color you are seeing here? I cannot hear. Golden. Okay, probably the screen resolution also shows us. It shows somewhat the yellow, green, or pale green, something. Okay. So now the same curve, I shine light. Now you can see it shows the different colors. That's why it's called dichroid. Di means two. Chroid colors. It exhibits different colors when you shine particular light here. So why the color changes? Because glass. See, you look at your window glass. Is it color? Is it color? No. But why this glass color? How they make this glasses color? This question of light. But I say light can because the light. Metal. Just put some metal in your glass and you get glass. So that's how we get kind of gold and silver metal. So then you can make it here. The metal is blue. It's a complement. That is a color reading. What color material you see the opposite color. Okay. So this gold materials, which you all came across this term. Okay, so it's a material with a dimension of 10 power minus 9 meters. Can we see your eyes? Millimeter. So then how do you nano not known microfarad gold body? It's a minute, there's I mentioned, very small than that much. But this word nano was done by Audio Technology in 1974. So then the first book came in 1986, Nanotechnology, or the engines of creation, a coming era of nanotechnology, or the engineering of functional system at the molecular scale. So, you know, water, what is the molecule? H2O. So how this molecule is formed? What is the formula? H2O is said. What are there? There are two hydrogen and oxygen. So that means two hydrogen atoms, one oxygen atom combined to form a water molecule. So that is a molecule. So if several molecules combine, so Avogadro number of molecules, 6 in 10 power 23 molecules. Okay, to call 1 mole of a substance. So then you increase the number, then you see whatever we see bulk materials, like gold, whatever you see is a bulk. But at this nanotechnology, you are going back to decrease the size, so again to closer to the molecular. So that's the nanotechnology. So for example, if human hair is 50,000 nanometers thick, or water molecule the diameter is 0.3 nanometers. Or there is a carbon nanotube, so which is 1.2 nanometer, the diameter of the tube. Or a transistor has been made 20 nanometer, or a DNA which is 2.5 nanometer, or a visa protein is 10 nanometers. So these are just few examples. Or more clearly, if you want, I can show here. You can compare this. So this is our Earth. So the diameter is 12,756 kilometers. So that means 1.25 10 power plus 7 meters. Whereas this is your football. The size diameter is 22 centimeters or 0.22 meters. But now I am showing a molecule which is consisting of 60 carbon atoms. Very good. It's called Buckminster Fullerene, 360 molecule. Fullerene. So the diameter is 0.7 nanometer. That is 0.7 10 power minus 9. From 10 power plus 7, 10 power minus 9. So now you imagine what's the size you are talking about when you are saying a nano. Right? Carbon also has a different forms. So diamond or graphite. So graphite in diamond, each carbon is surrounded by 4 carbons, sp3 hybridization, so it is insulated. Whereas here, each carbon is surrounded by 3 carbons. There's 1 electron is available. It forms a pi bond, so that the electron is freely moving, so it's conducting graphite. But it has a layer structure. The sheets are held together by van der Waals force. But you can also remove these sheets, then it's called a graphene. So one group, what they did is, it's also, they have in that lab as the Friday experiments, crazy experiments. So they do this, they have taken a graphite, so graphite will be bulk. You know the Scotch tape we use for, or use cello tape, similar to that. Just paste Scotch tape, then remove it. Few layers of the graphite, few layers will stick to that your tape. Then paste the tape on another surface, again remove, again paste on another surface like this. Then you can get 2 to 3 layers of this. That's how they discovered with graphene. The simple, crazy experiment what they thought, but they got a Nobel Prize. because graphene has wonderful properties, much higher conductivity than the graphite. It is being used in many places now. The another form is the fullerene 360. The another one is a nanotube. Just roll this sheet. The paper sheet, suppose if you roll tube, am I right? So if I roll this, I get a tube. So that's all the nanotube. So graphene sheet, you roll it. So then, depending on which side you are rolling, so you get a different types of structures, like zigzag or armchair or chiral. Then their properties are different. So this is the carbon. If you look at the people started proton they worked in 1970s. They want to make a long carbon chain. Like you have the aliphatic molecules, right? So, but similarly, only carbon can you make. So that's how they are working. But suddenly they discovered something through their mass spectrum. There is some signal coming at 60, so they found the 360. That is the carbon 60. So similarly, the Japanese scientist Ijima, he was analyzing carbon samples using electron microscope. He found these nanotube structures. So, and these nanotubes have been used by Samsung in the display, and IBM also used them as in the transistor. So this experiment made by Andrew and Overstead, the graphene SCoP experiment. So they got the Nobel Prize in Physics in 2010 for their groundbreaking experiments for the 2D material, two-dimensional sheets of graphene. So then nanomaterial means there is another important name which you come across. It's Richard Feynman. So he is a physicist, American theoretical physicist. He was also Nobel laureate, and he asked a question. He also mentioned there is a plenty of boom at the bottom. So what does it mean? So if you are looking, or if you are sitting in a first floor, you can say there is plenty of room at the bottom, right? If you are in a first floor, you would say there are several rooms in the ground floor bottom. That means you have something to go and occupy, or you can find something. So you decrease the size, go down. So size, you narrow down or bring down, then you get there is something new to discover. There is a lot of things interesting. That's the meaning. When you read this statement, there's a plenty of room at the bottom. He also has another question. What would happen if we could arrange the atoms one by one the way we want? We know water, H2O. So it forms, so the shape is V shape of the molecule. So similarly, can I arrange the atoms the way I want? Can you write something using the atoms clusters? So this is a question we made. So let's see, remember this question. Okay, I already slide. So this has a gold particles. So because there is a sulfur, that coordinates the gold and stabilizes the colloid. You might have studied what is a colloid, okay? So suspension of particles in a medium. So, but now people later they made these similar, instead of carbon disulfide, you can have other sulfur containing molecules, long chain molecules. So that stabilizes this gold. You can see this is a transmission electron microscope. So you can see these are small gold particles. The size of this is a 5 nanometer length. So this will be 3 nanometers or less than that. So now we have something to look at these nano-sized objects. So that's the electron microscope. Okay. So it's the same experiment. Similarly, reduce this gold, but instead of only one sulfur, like here, I can add a different molecules. So then I can change the size of the gold, number of gold atoms, the cluster, or the shape, everything you can play by choosing a proper sulfur containing molecule, which is known as a capping agent. Like this, it goes and anchors on the surface of the particles. So once you have this particle, another particle cannot come here because you have this molecule which will block. It's called a steric hindrance. So it will not allow the other gold to come and join with the other gold to make a bigger particle on this later. So it won't form because of the steric inwards. Also, there will be some electrostatic charge. It will stabilize the colloid gold. So now we know the chemistry. Earlier we didn't know what is nano or what makes it. Now we understood the chemistry. So we can make different. And these type of molecule or gold clusters are finding a lot of application as a drug delivery. If you want to send the drug to a particular tissue in our body, so you can use that as a carrier and target the cell, and you can destroy like cancer cells. If you put a radiation, it kills other good cells or the live cells also, am I right? So, but if you use this kind of target molecules, so they call them photodynamic or hydrodynamic or magnetodynamic therapy using nanoparticles. So, as I mentioned, this again compare the gold. So, gold we prefer as an ornament. Why you want the gold for making ornaments, jewels? It's expensive, am I right? The prices keep on increasing, but still we prefer gold. You know, what about just make a iron or copper?
It will not react.
Very good. It's a unreactive. It's not reactive. That means it doesn't react with the environment. Silver is also you are using, but you buy some silver anklet or silver ornaments. What happens after a few months? It gets oxidized. So how do you know that it's oxidized? It's a black color. Okay, the surface silver is not as stable as the gold or platinum. Okay, so that's why we use them as an ornament. So very good. So you all know this information. But as a chemist, once you complete your chemistry graduation, post-graduation, research, you go to lab. You take this gold. I take my ring or bulk gold. I put it. I want to do some reaction. Nothing will happen. Am I right? So you're not getting excited. Nothing happens. What is the use? As a chemist, you want to do something new. You want to discover something. So gold is not reactive when it's a bulk. But the same gold, when you reduce the size, few nanometers, you stabilize on the surface of the titanium dioxide. So it does wonderful oxidation. The CO2 or carbon monoxide, it oxidizes to carbon dioxide. So that's what we need for our vehicle exhaust. So we use the platinum catalyst. So platinum on lithium dioxide is used in our vehicle's exhaust. So it converts all the carbon monoxide which is coming out. So that's more poisonous than carbon dioxide. So we need to oxidize. So but gold also does this job only when the size is smaller. So that's the beauty of size reduction. Why we are interested in nanomaterials? Because you are giving a new properties. You are discovering a new property for the same material in a different size. When you have a bulk, it's not reactive. But now it's reactive because you decrease the size, there is a surface properties changes, there is more energy, surface energy, can absorb molecules. Okay, a lot of things happen, and that's why this field has a lot of interest. The same gold has been used in Ayurveda. We call the gold puspam, Tanga puspam. Okay, have you heard this? So in Ayurveda, they give medicine that contains a gold, so that also ground the fine powder. So that means it is having a small size of gold. So then only it is having the effect. So if you analyze that gold puspam, you have the gold at 96.7%, and it has the silica iron oxide, calcium oxide, and salt, sulfur, and moisture. Everything is present in that one. So this has been used. So earlier we have been using this nano, like whatever Michael Faraday prepared, also nanoparticles. This gold in Ayurveda also nanoparticles. But only thing we now know the name. We could see the size, dimension. Earlier no electron microscopes. This is the butterfly. The butterfly has a beautiful colors of the wings. So how the color comes? Where they get this color? It's not the paint. Because if you look at these wings in electron microscope, you take out the small portion, you can see this structure. But then again, you zoom it, this particular region, you enlarge, you can see a nice pattern. So you might have studied the grating, optical grating in physics in experiment. That means you send a light, you can separate the wavelengths. So same thing happens. The light scatters. Optical grating. So all this happened because of the developments in the instrumentation. As I mentioned, our observation, the eye can only see 0.1 millimeter. That's our resolution. Which below smaller than this, we cannot see. How do you see the red blood cells and other things? So we are using an optical microscope. But again, there is a restriction. You can see only 1 micron. 1 into 10 power minus. So if it's smaller than 1 micron, optical microscope also cannot view the objects. So we use the electron microscope because I mentioned electron has dual nature. It can behave as a particle, also it can behave as a waves. So this can be tuned, the wavelength of electrons, by applying a magnetic field or applying a different energy. So you can change the energy of the wavelength. So wavelength can be changed. Through which you can see the objects. So that's how you are seeing the objects. For example, the gold or the butterfly wing. What you are seeing, that's because of the electron microscopes, the instrumentation or revolution in the instrumentation. Okay, so the application of nano, I can show you here in electronics. So there is a famous Moore's law, the Gordon Moore. So he is a co-founder of the Intel, whatever we are using our computer or disk, okay, Intel. So he made a statement that is the number of transistors on a chip roughly doubles every 2 years. So how many number of transistors we have on a chip? So the same number after 2 years, it doubles. So he made a graph from the late 1960s or 70s. So how it's going to improve? You can see here. So that time it is about 10 power 3, 1000 transistors on a particular dimension of the chip. But now you can see in 2005 it is 10 power 8, and even now it's much more. So that's called the Moore's law. So now you can use a transistor made of this carbon nanotube. So you have a transistor, the source and drain. So you can connect. You can make them with a distance of 80 nanometers. So you can control them using various instruments. You can play with them. So that's how the development. So this is the first generation computer which will occupy a big hall. But later, second generation, third generation, fourth, fifth generation. Of course, we have still the desktops, but we are using a laptop. Now we have a tab. Or even your mobile phone, which can function similar to computers. You are using internet, right? You have the processor there. So how this happens? It's all the size reduction, the electronics, the nano, making a small dimensions of your transistors. Okay, now you recollect the question asked by Mr. Feynman. What would happen if you could arrange the atoms one by one the way we want? Is it possible? Yes, you can see here IBM. It's written. So this is a nickel plate on the bottom. So these, all of them are clusters of the xenon atoms. So the blue ones. So few xenon atoms clusters you can deposit in a controlled fashion using a technique called scanning tunneling microscope. Okay, you can read them, you can manipulate. So it is possible. So you can reduce the size, you can make whatever the number of atoms, suppose gold, you can make gold 25, or you can make gold 50 or gold 100, but you're going to see different properties by having a different number of clusters or different shape or size. So everything has a different properties. So that's the beauty of the nano world. Okay, of course, these numbers also have been defined. If you look at the common literature, so Anu means we know atoms. The atom radius is angstroms, am I right? So 10 power minus 10 meters. So the nanometer is 10 power minus 9 or 0.1 angstroms. So that's known as Anu. Anu is defined as 1 divided by this fraction. So it's 10 power 9. Or you go to Coulomb. So it is again 10 power how much? 10 power minus 10, right? So you can go similarly. Now we know the femto. 10 power minus 12, 10 power minus 15, so you can all go. The same thing. Can you imagine this number? Critical. So what would be the answer for this? So it's all known. You can Google, you can go to the common units of measurements. Our ancient people have thought about many things without even the computers. They predicted astronomy, they predicted, okay? So a lot of things happen. So our brain is more powerful, but the only thing you need to use it. You know, people say that Einstein's brain is the one which is mostly used in the world, right? It's preserved, right? So our brain can function. So more than a computer, okay? So but only thing how to use it more creatively, ask more questions. So then you can get a creative mind and get innovations. Is it okay? Will you do this? See, suppose I'm teaching something, I'm showing something here. Don't believe all things. So it's okay, but you can find. You go and do it yourself. Explore. It says nano is 10 power 9. So minus 9 is a gold cluster. Is there any other cluster? Of course, silver clusters. It's all known. So can I make something else similar to this? So that's how you discover. So read more and more. Okay. If I'm teaching with some textbook, you say, okay, I can take this, I can compare with another textbook. So there may be explanation given a different way that you can understand and question everything. So if you have a definition, each word, try to understand what does it mean. Then your knowledge, you don't need to memorize it. Everything goes into your mind. You correlate with your nature, and you will never forget. Right? So another important thing, hydrogen. Nowadays, the future we are talking about the green energy and the fuel cell vehicles. So this is going to be the future, the green hydrogen. That is, hydrogen can be produced in a different way by burning from a coal or water, heating the water. So they are called different types of hydrogen, like black or brown, gray hydrogen, blue. Green hydrogen is the one which is made from renewable. So water, the renewable energy source. So you can use the solar energy. Convert the solar into electrical energy. Split water into hydrogen and oxygen using electrolysis. So that's called a green hydrogen. So that hydrogen and oxygen can be used, they can combine, they produce, they release huge amount of energy using a fuel cell to drive a car or bus. Fuel cells. You can go and find out what's a fuel cell bus, how it is operated. So what is the future? For electric vehicles, why we are talking about electric vehicles? We want to minimize the pollution by using the petrol or diesel, so we release a lot of CO2, the global warming. So we can go to alternate renewable energy sources. So you use batteries, you only need to charge. So get the electricity from the solar energy. Not only solar energy, you can get a different energy. Of course, this is just to compare from the literature, the different types of energy, hydrogen. But what we are looking at by 2030, we should have more of this green hydrogen by electrolytic process. And 2050, we have more of zero carbon electrolytic green hydrogen without any carbon footprint. So that's the target
we are looking at. So how you produce, you can produce from photoelectrochemical or low temperature electrolysis or using a photobiological, certain enzymes can also produce hydrogen in water. Okay. So a lot of things are happening. So only thing you need to use from this part of our subject science, how to use for the other application, that you should know. So knowledge should be wider. That's why it's interdisciplinary. Right? So our institute is mainly Central Electrochemical Research Institute, mainly focuses on electrochemistry related. And it's South Asia's largest electrochemical hub. So we have electronics and electrocatalysis for fundamental research, an electrochemical power source, which works on the batteries, fuel cells, like battery, lead acid battery, lithium-ion batteries, fuel cells, and electro-organic chemicals, how to produce organic molecules by electrochemistry. Some molecules very difficult to produce by organic reactions, but it may be produced by electrochemical means. Or similarly, electro-inorganic chemicals like hydrogen peroxide, so how to produce them. So they are having more applications. And similarly, corrosion, so how to prevent corrosion of iron or steel. So using electrochemical methods, or how to understand them. The materials electrochemistry, make some materials which can be used in the batteries or for the other electrolysis processes, electrode, or process engineering, or electroplating, or metal finishing, electrometallurgy. Like electroplating, so we use the copper coated, gold coated. So plating or power sources. So the future is again energy conversion and energy storage. So new and improved batteries, I stay for a longer time. I would like my car for 300 kilometers. I don't need to charge. So that's what I'm looking at. So fuel cells for transportation for cleaner environment. And similarly, solar energy conversion using photoelectrochemistry. Use this for splitting to hydrogen. So nitrogen fixation of CO2 to methane or carbohydrates. So that's how you can consume all the CO2 what plant does naturally, but that does done a slow process. But can we do it in a faster way? CO2 conversion by using electrochemical means. So this is how the energy can be converted into solar energy or the wind or the wave, tidal or the hydroelectric. So all things can be stored in different forms of a battery. So either lithium-ion batteries or supercapacitor. So you can store it in the mechanical or electrical chemical forms. Okay, that's why electrochemistry is also important. So on plan for chemistry. A simple galvanic cell metal study. We take a zinc rod, dip in a zinc sulfate, copper rod in a copper sulfate, so put a salt bridge. So this reaction happens spontaneously. The zinc dissolves, the zinc 2+, the electron goes here, and the copper 2+ deposits on the electrode. So this is a galvanic cell. But this reaction can be reversed by applying a potential. Here I am not applying a potential. Here by applying a potential, you can reverse this reaction. We call this as the electrolytic cell. So that's how you can split water into hydrogen and oxygen. Okay, the electrochemistry can also go with the physics, physical electrochemistry, biology, bioelectrochemistry to understand the process happening in our brain, the neurotransmitters, how the electron transfer happens. So bioelectrochemistry. So sensing process happens. The quantum chemistry, you can use with electrochemistry, analytical chemistry, medicinal electrochemistry. So you can go along with all things, electronics, material science, technology of metallurgy, you can extract metals using electrochemical processes, environmental or computer science. So there is opportunities for you. So you are undergrad students, so continue with your masters. So go for MSc. Once you finish MSc, you can pursue research. Now you have many opportunities, many fellowships. There is a national level exam conducted by CSIR as a national eligibility test. So once you are successful, you qualify. So you are going to get a fellowship for 5 years. First 2 years you will be called a junior research fellow. You get 31,000 rupees per month. And after second year, you get 35,000 rupees per month. It's more than enough for you. And you are going to study, you are going to get the highest degree in your life as a PhD. Am I right? That's the highest qualification. You are also getting money, you are also getting degrees. So there is another fellowship by Department of Science and Technology, Inspire Fellowship. If you become a university topper, gold medalist, you are eligible to apply for this. So again, you get a similar fellowship for 5 years to do your research. Or the University Grants Commission, UGC, also conduct this JRF, UGC, lodging and the national scholarship. So many opportunities are available. The only thing you should pursue. So not stopping after BSc, say I'm going to get a job or I'm going to stop studying. No, you can continue. You have got this golden opportunity. I've shown compared some of the students, they don't have opportunity to study, but still they have creative mind. Given opportunity, they will be successful. But now we got this better opportunity to come to this level. So then from here, how to proceed. So continue your studies. There are many fellowships available. So you can continue your research. You can become a scientist. Am I right? So then it's not only science, engineering also get more fellowships. So you can work with engineers ultimately to make your products. So everything is required. It's not that science only can do or engineering or technology only do. We need a combination. Okay, Mother India expects of you that your life should be clear, noble, and dedicated, selfless work. It's mentioned by Sarvapalli Radhakrishnan, who we celebrate the Teachers' Day. So he also mentioned we can't climb the mountain in our very basic speech. That means your foundation, basics, should be strong. What I mentioned, just go and read more. See, that's how our professors have advised us when we are in undergrads or postgrads. They said go to the library, read many textbooks. Don't need your knowledge. Then you can go because it's a world that's full of opportunities. So we don't know where our need is. Okay? So read more. The fundamentals should be strong. So I got this two Tirukural. So water will flow from a well to the depth, it is to the level water we take out. So knowledge also like this. So you should read more and more. So not only read, you should share. If I have to share some knowledge, then I need to learn. Right? If I want to take a class for you or it's a particular subject, first I should be thorough with that. So then I can go and read to share the knowledge. That means I create more knowledge. So similarly, so to discern the truth in everything, by whomsoever spoken is wisdom. So whatever I have mentioned here, it's only glimpse. I can call tip of an iceberg. So there's a lot of things have been done. During the nano, the last 20, 30 years, so much have come. I only gave some basics what is nano. Okay? So you can go and explore. That's how your wisdom. Don't take whatever I have mentioned here. That's enough. No. Go and find the truth. You can think, why this can be like this? This can be something else. You can disprove something by having some experiments. Then you become a discoverer. Innovation. Okay? So this may be my last slide. There's not somebody or something. So stand up, be bold, be strong, take the whole responsibility on your own shoulder, because you are the creator of your own destiny. If you want to study, if you want to excel, you have the opportunity. The world is full of opportunities. So only thing how you use, how to grasp knowledge and how to excel. So make your own future, right? Swami Vivekananda. So keep going. That's my final slide. If you have any questions, thank you for your patience for listening. Thank you, and I wish many scientists from this group should come in the future. Am I right? So if you have anything, you can write to me. I give my email. Plus one and here. Okay, let's go for program. Okay, sorry. Okay, any questions? We follow whatever I said. You go and read more. You explore. Yes or no? Yes. So I thank the organizers. Okay, teacher Anabidan and Dr. Lekmar, the college management, principal, all of you for this wonderful opportunity as we celebrate the National Science Week Festival. So it's not that science is also important, science and technology are going together. Thank you very much.
Thank you, sir. Thank you for your very nice presentation. I think all are enjoy. Not enjoy, learn something today. It's a different topic and different எப்படி சொல்லலாம், ஒரு புதுவிதமான ஒரு அனுபவம் கண்டிப்பா எல்லாத்துக்கும் கிடைச்சிருக்கும். இந்த அருமையானதொரு நமக்கு இந்த அறிவியல் சார்ந்த ஒரு தகவல்களை நமக்கு வழங்கிய CSIR சிக்ரியினுடைய முதுநிலை விஞ்ஞானி ஐயா அவர்களுக்கு ஒரு பலத்த கைத்தட்டலோடு இந்த ப்ரோக்ராம் நம்ம காலேஜ்ல நடத்துறதுக்காக நான் பர்மிஷன் கேட்டப்போ நம்மளுடைய கல்லூரியினுடைய முதல்வரும் செயலர் அவர்களும் அதோடு 2 ஒருங்கிணைப்பாளர்கள் ஐயா ஜெயக்குமார் சாரும் சோமு சாரும் ரொம்ப ஆர்வத்தோடு கடந்த 3 நாள் தான் இந்த ப்ரோக்ராம் ஆர்கனைஸ் பண்ணோம். அதுக்கு முழு ஒத்துழைப்பு நல்கியதற்காக பை தி ஆர்கனைசர்ஸ் டீம்ல இருந்து மனமார்ந்த நன்றிகளை நாங்கள் கல்லூரி அனைத்து ஒருங்கிணைப்பாளர்களுக்கும் பேராசிரியர்களுக்கும் தெரிவித்துக் கொள்கின்றோம். 75வது சுதந்திர தினத்தினை கொண்டாடும் விதமாக இந்த இந்தியா முழுவதும் கடந்த 22 முதல் 28ஆம் தேதி வரை முக்கியமா சொல்லணும்னா அறிவியல் மற்றும் ஆராய்ச்சி நிலையங்களில் அதிகமாக தேர்ந்தெடுக்கப்பட்டது. அது நம்ம கோயம்புத்தூர் பகுதியில தான் நிறைய கல்லூரிகள், நம்ம தமிழகத்துல தான் நம்ம இப்படி பிளான் பண்ணி நிறைய கல்லூரி மற்றும் பள்ளிகள்ல மாணவர்களுக்கு அறிவியல் சார்ந்த விழிப்புணர்வினையும் ஆராய்ச்சி துறையில் அவர்களை ஈடுபடுத்த வேண்டும் என்ற ஒரே ஒரு நோக்கத்தோடு தொடர்ச்சியா நம்ம தமிழகத்துல 5 இடங்கள்ல திருச்சி, மதுரை, திருநெல்வேலி, சென்னை மற்றும் கோயம்புத்தூர் மண்டலங்கள்ல நடைபெறுகிறது. கோயம்புத்தூர்ல மட்டும் கிட்டத்தட்ட நியர்லி 40 பிளேசஸ்ல 22 to 28 வரைக்கும் நம்ம இந்த சயின்ஸ் வீக் ஃபெஸ்டிவலை செலிப்ரேட் பண்றோம். ஸோ அதற்காக இந்த முழு ஒத்துழைப்பு நல்கிய அனைத்து இந்த கல்லூரியினுடைய முதல்வர் உட்பட அனைத்து பேராசிரியர் பெருமக்களுக்கும் மாணவர்களுக்கும் மனமார்ந்த நன்றிகளை ஒருங்கிணைப்பாளர் குழுவின் சார்பாக தெரிவித்துக் கொண்டு கடைசியா ஒரே ஒரு ஸ்டாண்டர்ட்ல நான் முடிச்சிடுறேன். சூரியனை போல நீ பிரகாசிக்க வேண்டுமானால் எப்படி இருக்கணுங்க? நம்ம சூரியனை போல முதலில் எரிவதற்கு நாம் தயாராக இருக்கிறோம். நமது பிறப்பு ஒரு சம்பவமாக இருக்கலாம், ஆனால் இறப்பு ஒரு சரித்திரமாக மாற வேண்டும். இன்னைக்கு நின்றுக்கிற ஒவ்வொரு விஞ்ஞானிகளும் கட்டாயம் ஒரு இடத்துல நிறைய ஸ்ட்ரகிள்ஸ் எல்லாத்தையும் பேஸ் பண்ணி தான் இன்னைக்கு ஒரு மிகச்சிறந்த விஞ்ஞானிகளாக மாறி இருக்கின்றார்கள். அவர்கள் கல்லூரி சார் சொன்னது போல ஒரு மாற்று சிந்தனையாளர்களாக ஏன் எதற்கு எப்படி அப்படிங்கிற ஒரு கேள்வியினை நமது பள்ளி பருவத்திலே கேட்கணும். அதை தாண்டி நம் கல்லூரி பருவத்திலே நம்மளுடைய டிகிரி வந்து நம்ம சயின்ஸ் டிகிரி படிக்கும் போது அந்த கேள்விகளை எப்போது நாம் கேட்க ஆரம்பிக்கின்றோமோ அப்போதே நீங்க விஞ்ஞானியா மாற ஆரம்பிச்சிட்டீங்கன்னு அர்த்தம். அதற்கான ஒரு சிறு விதை இன்று தூவப்பட்டிருக்கிறது சரஸ்வதி தியாகராஜா கல்லூரியிலே. கட்டாயம் நாளை வந்து இந்த கல்லூரியிலிருந்து பல விஞ்ஞானிகள் உருவானால் அது கண்டிப்பாக நமது கோவை மண்டலத்துக்கு பெருமை. எல்லாத்துக்குமே தெரியும் பத்மஸ்ரீ முனைவர் மயில்சாமி அண்ணாதுரை அவர்கள் நமது மாவட்டத்திலே இருந்து சந்திராயன் என்கின்ற உலகமே புகழப்படுகின்ற, அதே போல மங்கள்யான் என்கின்ற மிகச்சிறந்த ஒரு செயற்கைக்கோள், இது இரண்டும் உலக அளவிலே நமது இந்திய நாட்டினை திரும்பி பார்க்க வைத்த 2 நிகழ்வுகள். கட்டாயம் நம்ம மறக்கவே கூடாது. நம்ம அந்த கொங்கு மண்டலத்தினுடைய ஏதாவது சொல்லுவோம் இல்லைங்களா, நமக்கே உரித்தான ஒரு பெருமை. அந்த கொங்கு மண்டலத்திலே அப்படி பேர் சொல்லக்கூடிய அடுத்த தலைமுறையில நீங்க எல்லாம் வர வேண்டும் என்று வாழ்த்தி இந்த அருமையான ஒரு வாய்ப்புக்கு நன்றி பாராட்டி நமது சிறப்பு விருந்தினருக்கு ஒருங்கிணைப்பாளர் குழு சார்பாக ஒரு நினைவு பரிசினை வழங்குகிறேன். இந்தியன் மைண்ட்ஸ், ஏன்னா அதாவது நம்மளுடைய இந்திய விஞ்ஞானிகள் எப்படியெல்லாம் வளர்ந்து இன்றைக்கு வந்து நம்ம இந்தியாவினை வந்து பல இடங்களுக்கு, அதாவது உலகம் முழுவதும் வந்து அவர்கள் வந்து பேசப்படுகின்ற அளவுக்கு இருக்கிறார்கள் அப்படிங்கிற சார்ந்த ஒரு விஞ்ஞான் பிரசாரனுடைய புத்தகம் ஐயா அவர்களுக்கு வழங்குவதிலே மனமார்ந்த அவருக்கு வாழ்த்துக்களை தெரிவித்துக் கொண்டு நன்றியை தெரிவித்துக் கொள்கிறோம். நன்றி ஐயா.
Okay, one more information. You have another option. You are a BSc student. So there is a summer research fellowship, which I forgot to include here. You can note down Indian Academy of Sciences. Yes. Or Academy of Science Academies. Now there are 3 academies in India. They combinedly offer summer fellowships. Earlier only it was for master students after first year MSc, but now they also offer for BSc students as well as engineering students. So you can apply. Every year they give for 2 months in your summer. You can choose whether from May to July, or it depends on. You can go and work in IITs or in CSIR labs. So there are many guides are available. So we used to get, when I used get some students from the North India. Usually they send from North people to South because to learn the culture as well. And South Indian students, they can go to North. Sometimes it's possible you can get in Tamil Nadu or nearby states. So make use of these opportunities. So Science Academy Summer Research Fellowship. So you need to only upload some small write-up. If you are a chemistry student, you say, I want to work in this kind of area or something. Then they have a list of guides they will assign you where there is a matching. So 2 months you get a scholarship. So you get accommodation. Some of the institutes they provide accommodation also. So it's a good opportunity to go and interact with the scientists and work in the lab to get idea what's happening, how research is done. But you will add even in your biodata, you can say I have a summer research. You can go to IITs, Indian Institute of Science or CSIR labs. We can get many students every year at degree. Okay, so this is one opportunity you can find. So you can explore. So you can apply and make use of this. Okay, so 2 months you will be exposed. And sometimes if you are good enough, you work some results come, you can publish papers. So some of my summer fellows, we also publish some papers together. Okay, so make use of this opportunity, which I could not include here. Summer research fellowships. Okay, thank you very much.
Thanks for your thank you for your wonderful presentation. I'm having a doubt regarding the luminescence phosphorus, because in the present day LEDs, that is blue LEDs or some white LEDs, there is a lack of red component. Red component is lacking. We are choosing phosphorus. Then we work with something. We have to prepare some electroluminescence or some other luminescence based things that is displayed. So the efficiency is very low. How to overcome these kind of lower efficiency? But the stability wise, it was okay in the sense the chemical and stability.
Thank you for your question, and it's the right question. Because mainly whatever the blue, white media and so on uses gallium nitride, whatever the yellow emitting phosphor. So normal sometimes the blue component is small, the ratio doesn't match. So you can have a blue. That's why they say the blue light is coming from the LED, right? You might have heard the blue rays is not good for your eyes. So the color rendering property of the existing yttrium, aluminum garnet, the helium phosphor. So a lot of research is going on to find the alternative material for this, because it's yellow emitting. Let's say you need to include some red component to add, maybe the color purity will improve and color rendering index. So that also will improve. So of course, the efficiency, it is a matter of, it depends on a lot of other factors. Okay, so what is the type of the Hauss lattice? So the lattice vibration, sometimes they cause quenching the emission intensity. So a lot of work is being done. So some the nitrates they work on the oxides, oxynitrides. So with the different barrels also. Europium is good for that, but still you can have Europium along with the other things to improve the color rendering properties.
Like photopic.
Yes. So still a lot of work is going on.
Students, do you have any queries or you want to interact with our scientists? Anybody? You may be having some doubts about your future, like you may want to work in you want to work in this laboratory. If you have any doubts regarding that, you may ask now. Don't hesitate. We have a principal scientist with us. If you have any doubt, you can ask. Okay.
Thank you, sir. Gratitude is a powerful catalyst for happiness. To show our gratitude, we request Mr. Sudha, Associate Professor of Chemistry, to give a vote of thanks. I think it will be a great honor and privilege to propose to the vote of thanks on this memorable occasion. Let me first of all start by giving you glory to the Almighty God for making today's occasion a resounding success. First and foremost, I thank our special guest, Dr. N. Lakshmi Narasimhan, Principal Scientist, CSIR, Sikri Karekuri, who, despite his busy schedule, has found time to grace occasion. Thank you, sir. And also express my heartfelt thanks to Mr. Kanabran, Joint Coordinator, VSB, Radio Science Club, Gurmanpet, for his valuable contributions towards this prestigious event coming to grand success. Thank you, sir. We are grateful to our management for their words of encouragement and their able guidance as always encouraging us. I thank them for their kindness, interest, hospitality, and continued support. I thank our well-wisher Principal Dr. A. Somu FTC for his priceless support, vision, and commitment. My heartfelt thanks to Professor Sivaswamy, Dean Mathematics, Dr. Senil Amudar, Dr. Rajrathaman, faculties and students for Science Department for their valuable contributions, guidance, and encouragement to all our efforts. And my heartfelt thanks to Department of Tamil, English, and Mathematics for their support to evaluate the competition. I owe special thanks to AO Thiruvelayam for arranging the festivities to the event. Also, I would like to thank all non-teaching staffs, especially Humayun sir, for his technical support. I would like to thank Electrician Sundaram
Shivakumar and lab assistant M. Kandasamy, who have worked hard to ensure his occasion becomes memorable success. I would like to thank students from the photographic club of our college to make this event noticeable in and out of this college. I thank all distinguished invitees present here accepting our invitation, and I thank all good hearts who worked behind the success. Last but not least, I thank you, my friends, for your cooperation in making this function a resounding success. Thank you. Thank you, ma'am, for your gratitude.
Live life to the fullest and focus on the positive. The best is yet to be. With that positive vibes and be bringing best out of yourself, we are winding up. Before that, it's time for patriotism. Kindly rise for national anthem.
जय जय मंगल दायक जय हे भारत भाग्य विधाता